These are notes for Melham's Math 60, Tuesday, April the 21st, section 9.1, page 760. Changing the homework a little bit, you can skip problems 49 to 55. Skip 49 to 55, they won't be assigned for any homework or quiz or test. And speaking of the test this coming Friday, the 24th, it will not cover 9.1 or 9.2, which is I'm going to cover tomorrow, or 9.3 on Thursday. It's just a chapter 8 test. We'll have the chapter 9 test the following week. Okay, we're going back to doing more work on functions, the f of x and g of x and so forth. Here's problem 15. F of x is equal to 2x plus 1. G of x equals x minus 3. They're asking for the function g minus f, so I take the function x minus 3 in parentheses minus f in parentheses 2x plus 1. It's crucial that you make sure to put the parentheses because if you don't, you'll get the wrong answer. And then we distribute x minus 3 minus 2x minus 1, and that comes out to be negative x minus 4. It also asks for the domain. I'll abbreviate domain as D if we know we're talking about the domain. Well, the domain is all real numbers. When I take the expression negative x minus 4, I have no trouble with plugging in any real number. Any real number, you can take the opposite of it and subtract 4 without any issue. You're not dividing by 0, you're not taking the square root of a negative or anything like that. So, all real numbers for the domain. Here's 17, is asking for f times g, so I just multiplied 2x plus 1 times x minus 3, that just looks like FOIL, first, outer, inner, last, comes out to be 2x squared minus 5x minus 3. And once again, for polynomials like this, the domain is all real numbers. No matter what real number you give me, I can always square it. I can multiply it by 2, I can multiply it by negative 5, add these, and subtract 3, so that's not an issue. Again, we're not dividing by 0, we're not taking the square root of a negative or anything like that. For 27, a little bit different. F of x is given to be 3x, g of x is 4x. They ask for g over f, so that's 4x divided by 3x. Now in this particular case, the original functions were 4x and 3x. I'm not allowed to plug in 0 here. After I cancel, I have 4/3, but I have to remember the original function was 4x over 3x, where x is not equal to 0. So for the domain, I'm going to put all real numbers, the funny looking r, minus the set consisting of 0. So this is our way of saying that we're throwing out 0. Now if you look in the back of the book, they'll write something different. It's equivalent, there's nothing wrong with it, but I like this better. It's more suggestive. I just want all real numbers except for 0. So set of real numbers minus, and then in braces, if you want to list a set of numbers, then the braces is what you want to indicate, and I'm throwing out the 0. Here's number 33. S of x is 3 minus x. F of x, t of x is x squared minus x minus 6. All right, so they want s times t of negative 2. So that means s of negative 2 times t of negative 2. So I plug in negative 2 for s. 3 minus a negative 2, that comes out to be 5. And plug in negative 2 for t. That's negative 2 squared minus a negative 2 minus 6. That's 4 plus 2 minus 6, which is equal to 0. So if I go back to s of negative 2 times t of negative 2, I got 5 times 0, which is just 0. Here's 37. F of x is 2x plus 1. G of x is x squared minus 1. And this time we're doing something called a composition of functions. F circle g of 2, looks like fog. That means f of g of 2. So that means I do g of 2 first. This is not a multiplication. It means I really do the inside first. I do g of 2. So g of 2, put a 2 right here. 2 squared minus 1, that comes out to be 3. And now I do f of 3. So I take that 3 and plug it into the f function. 2 times 3 plus 1, and the answer is 7. Here's 43. G circle f of 2x. That means g of f of 2x. So again, do the innermost parentheses first. Pretend you just do f of 2x. So 2x goes right here. That's 2 times 2x plus 1. And that comes out to be 4x plus 1. Then I apply that to g. So this expression 4x plus 1 goes right over here. So it's 4x plus 1 squared minus 1. 4x plus 1 squared is 16x squared plus 8x plus 1. And then minus 1, the ones just cancel out. So 16x squared plus 8x. Problem 45 asks you to look at the graph, so I just pasted, this is the graph for problem 45. They have two functions, f and g. In the book it shows it to you in color, but here I just made a black and white picture, but that's okay. So we just read everything off from the picture. So for A, f plus g of -5 means f of -5 plus g of -5. Now remember, when I look at f of -5 or g of -5, these are x values. In parentheses at the x, they're asking you for the y. So f of -5 for the f function, which is this one, I go to x is -5, I come back with the y coordinate, which is 3. Okay, so when I say f of -5, it means when x is -5, what's the y for the f function? For g of -5, that means I'm looking at this one. So when x is -5 for the g function, the y value is -3. And then I add them. 3 plus -3 is equal to 0. Part B asks for f minus g of 3. So that's f of 3 minus g of 3. So again, for the f function, g of 3, 1, 2, 3, that comes out to be 3. Minus g of 3, so the g function of 3 is down here, that's -3. So I'm doing 3 minus a -3, which is 3 plus 3, or 6. And then finally, C, it says f times g of -3. That means f of -3 times g of -3. So f of -3, -3 is right here. The y coordinate for the f function is 1. G of -3, so for the g function, 1, 2, -3, the y coordinate is -3. So I do 1 times -3, which is just -3. All right, then 57, f of x is 3x minus 2, g of x is x squared plus x. The question asks for f circle g of 4, which means f of g of 4. So first I do the inside, I do g of 4, so 4 goes here. So I want f of 4 squared plus 4. 4 squared plus 4 is 16 plus 4, which is 20. And now I take that 20 and plug it into f. So 3 times 20 minus 2. 3 times 20 is 60. 60 minus 2 is 58. 63 asks for g of f of x. G circle f of x means g of f of x. So what is f of x? Well, it's 3x minus 2. So I want g of 3x minus 2. So now this whole expression, 3x minus 2, goes right here and right here. So it's 3x minus 2 squared plus 3x minus 2, and then clean that up. So 3x minus 2 squared comes out to be 9x squared minus 12x plus 4, plus the 3x minus 2. Clean that up, 9x squared minus 9x plus 2. Okay, 71 asks for g circle f of 8x, where f of x is 1 over x, g of x is 1 over x squared. So I'm doing g of f of 8x. Sorry, I made a mistake here, so I had to wipe that out, and I couldn't squeeze that in, so 8x belongs right inside there. As you can see, I put that right over there, so that should be an 8x inside. So f of 8x is just 1 over that, so 1 over 8x. And now this expression goes into g. So g is 1 over x squared, so it's 1 over 8x squared. It looks like it's double top, but it's 1 over a fraction. If you have 1 over a fraction, remember, if you divide by a fraction, you multiply by its reciprocal. So it's 1 times 8x quantity squared divided by 1. You don't have to write divided by 1. And so we get 64x squared. Finally, 75, they say f of x is x squared minus 1. G of x is x squared minus 4. They simply want g divided by f. So that divided by that, x squared minus 4 over x squared minus 1 is the answer. By the way, if you think you can simplify this, no, you can't. Don't cancel out x squared or whatnot. They do ask for the domain, so the harder question perhaps is, what's the domain of this function? Well, we know we're never allowed to divide by 0. So I'm essentially asking, when is x squared minus 1 equal to 0? Add 1 to both sides, x squared equals 1, do the square root property, x equals plus or minus 1. In other words, if I plug in 1 in the denominator, I get 0, and that's a no-no. If I plug in -1, -1 squared is also 1, 1 minus 1 is 0. So plus or minus 1 makes the denominator 0, so they have to be thrown out of my domain. So the domain is all real numbers minus the set consisting of plus or minus 1. This is another way of saying all real numbers except for -1 and +1. Again, if you look in the back of the book, they have another way of writing the solution, which is correct, but it's a little bit less intuitive. I think this is much more obvious. All real numbers except for 1 and -1. And so that's the answer for that one. All right, so these are notes for Melham's Math 60, Tuesday, April the 21st, section 9.1, which will not be covered on this Friday's exam. This Friday's exam is just chapter 8. So tomorrow we'll go on to 9.2, Thursday 9.3, and then we'll stop Friday to take the chapter 8 test.